When you think about cloud computing, public or private, the big promise, right? It really boils down to agility, speed.
Yeah, that rapid on-demand service delivery.
Exactly, giving users what they need when they need it. But it's interesting. We talked about this before. Achieving that speed, it isn't really about the hardware itself.
No, not the raw server speed. It's all about that intelligent software layer on top.
The operational brain, you could say,
Mm,
and the user interface, the cloud management platform, or CMP.
that's it precisely. The CMP is absolutely critical. It's the gateway, really. It turns a pile of virtualized resources into an actual measurable, governed cloud service.
Right. Without a good CMP, you've just got a very expensive data center that's probably quite hard to use.
Exactly. Just infrastructure hosting, not a cloud service.
So today we're doing a deep dive into the key functional considerations. What do you need when you're selecting or designing a CMP? We're drawing this directly from the lesson that laid out these requirements.
Right. And the mission here is to get practical. Move past the buzzword cloud and really focus on the specific functions that let an organization deliver genuine cloud products,
Not just hosted VMs.
not just hosting. So yeah, we'll unpack the essentials, how users get stuff immediately self-service, how you track consumption, for costs,
The automation engines behind it all.
the elastic engines, yeah.
Yeah.
And of course, the security and governance layers, you absolutely need those to keep things compliant and safe.
It's a huge functional footprint when you list it all out.
It really is.
Okay, let's start right where the user connects. The foundation of that speed we talked about, self-service.
Makes sense. That's the entry point.
Because if a user still has to log a ticket and wait maybe weeks for IT to spin up a server, well, you haven't built a cloud, have you?
No, you've just maybe virtualized your data center. The critical process layer hasn't changed. That faster service delivery is the entire business case for the cloud model.
Absolutely. But okay, designing that self-service part, it's tricky, right? You've got such a wide range of users.
That's the immediate challenge, yeah. A really diverse user base.
We often think of self-service as just, a nice web portal, drop-down menus, easy to click.
The consumer interface,
Yeah.
right. And that works perfectly for someone who just needs a standard server, maybe simple database instance, quickly and easily. Ease of use is key there.
But that's not everyone.
Not at all. The design really needs to be, well, dual-layered, maybe even multi-layered. Think about the power users.
Developers, DevOps teams.
Exactly. Or anyone needing to bake service deployment into their automated pipelines.
Mm.
For them, API support isn't optional. It's mandatory.
That's a great analogy. The portal is the nice front entrance, but the API is like the high-speed industrial loading dock. It handles the bulk orders, the custom stuff, programmatically.
Perfectly put. And that API piece is just crucial for scale, isn't it?
Oh, absolutely. One person clicking in a portal, fine. But 1,000 developers needing environments spun up and down multiple times a day, the UI just becomes a bottleneck. A crippling bottleneck. The API lets them customize, integrate services into their own tools automatically. And crucially, it ensures idempotent operations.
Meaning the same call always gets the same result. Consistency.
Exactly.
Yeah.
Same input, same output, every time. And look, regardless of how they access a portal, API, command line security can't be bolted on later.
No, it has to be built in from the start.
The interfaces themselves must be secure, strong protocols, for the human side and the machine-to-machine API calls.
Right. So once someone gets access and provisions something, the focus shifts immediately, doesn't it?
Wow.
From access to accountability.
Yes. Which brings us neatly to the next foundational piece, metering.
Consumption tracking.
Metering, yeah. People sometimes think of it as, boring accounting stuff.
Yeah, maybe a bit dry.
But it's actually a really vital tool. It drives efficiency across the organization, resource optimization.
How does it do that? Well, it tackles that growing need for, strict budget control, tracking consumption everywhere. The main goal is helping the consumers, the business units, the developers, understand the real cost, the financial impact of the IT resources they're using.
Ah, okay. So when usage is directly tied to cost.
Exactly. It just organically encourages them to design things more efficiently, use resources wisely, decommission stuff they aren't actually using anymore.
That makes sense. But, okay, the source material highlights a pretty big operational hurdle here, the granularity challenge.
Oh, yes. This is a big one.
How do you actually measure consumption accurately enough to really encourage that optimization you talked about?
This is a huge point of debate in IT financial management, honestly. If you only meter based on what's allocated.
Like, did they reserve a VM instance? Is it turned on? That kind of thing.
Yeah, exactly. Or how much storage capacity did they reserve? You capture that usage, sure. but you might completely miss the waste.
You're billing for the potential, not the reality.
Precisely. So let's say a developer provisions a huge VM 32 cores, 128 gigs of RAM,
Okay.
but it sits there idle 95% of the time. Billing them just on allocation implies they're maxing it out constantly.
Right, which they're not. And that cost profile gives them zero incentive to maybe choose a smaller instance.
None at all.
Mm-hmm.
True cost optimization, the kind that really saves money, needs actual usage tracking. CPU utilization over time, actual data going through the network, the percentage of RAM they reserved that was actually touched by the application.
So much more granular data.
Much more. The closer you get to tracking actual utilization, the better the consumer can fine-tune their resource usage and cut down on that financial waste.
Yeah.
But and this is the challenge.
Yeah.
The CMP has to be able to capture, store, and process potentially billions of these tiny data points constantly to generate reports that are actually meaningful and accurate. It's a significant data handling job.
Okay, so resources are provisioned, consumption is being tracked, hopefully granularly. What's the CMP's next big job?
Acting as the central nervous system, basically. Making sure everything stays up, stays healthy, performs well. This is where monitoring and reporting really kick in.
Right, keeping the lights on and making sure the service levels are met.
Exactly. The CMP's monitoring solution has to ensure both the services the user consumes and the underlying infrastructure are available and performing as expected, meeting those SLAs, the service level agreements.
So what's the scope here? Is it just basic stuff like CPU temperature or?
Oh, it's way broader than that,
Yeah.
incredibly broad. Monitoring objectives cover, let's see, application availability, obviously, responsiveness of services.
Performance.
Yeah, performance. Infrastructure health, that's networking, storage, the hypervisors themselves, resource utilization across all the pools, and really importantly, spotting potential security issues or weird usage patterns, anomalies.
If the CMP can't see all that, you're essentially flying blind.
Completely blind. And the whole promise of elasticity, high availability,
Yeah.
it just falls apart.
Now, I think one of the most crucial functional distinctions here, based on the source, is understanding the difference between the provider's view and the consumer's view of monitoring.
Absolutely critical distinction. They need different information, different levels of access. It's not the same picture at all.
Okay, so break that down. What does the cloud provider, the central IT team running the show, need to see?
They're focused on the fundamentals, the operational guts. They need data to maintain the cloud fabric itself. Things like infrastructure errors, aggregate resource use across all the tenants, hypervisor health status, network performance on the backbone.
And their access is pretty deep.
Typically comprehensive, yeah. Often right down to raw infrastructure logs if they need it.
Okay. And then the consumer, the business unit, the app owner.
They really don't need or, frankly, want to see the nitty-gritty details of the hypervisor that's also running 5 other tenants' stuff.
No, probably not.
They care about their deployment, the performance of their specific application latency maybe, and, tying back to the last point, detailed consumption info linked directly to their budget.
And this consumer-facing view, this insight, it's vital for them, right? For planning.
Vital for planning, capacity management, and critically, for spotting those forgotten, unnecessary service instances.
Ah, the zombie VMs.
Exactly. If someone spun up a resource for a quick test 2 months ago and just forgot to turn it off, the CMP reporting needs to make that idle cost painfully visible.
So monitoring ties directly back into financial governance here.
It absolutely has to. But that visibility raises a governance question itself, doesn't it?
How so?
How does the CMP provide that detailed insight to the consumer without breaking the multi-tenancy security model? You don't want them accidentally seeing another tenant's performance data.
Right, yeah. That would be bad.
Very bad. That's why you have to be super careful about sharing raw data. Generally, sensitive infrastructure logs, they're kept strictly provider only. Voids violating privacy rules, obviously.
So how does the consumer get their view?
The CMP needs a dedicated reporting and sanitization engine. It extracts only the necessary relevant metrics for that specific consumer, like their app's latency, their VM utilization, and presents it in a clean, isolated dashboard.
Okay.
No cross-tenant visibility allowed. The CMP acts as this trusted intermediary. It cleans up and isolates the data before showing it to the consumer.
Okay, now we get into what really feels like the engine room.
Yeah, This is where the magic happens.
Where that self-service click or that API call actually turns into complex resources spinning up in minutes. It's that underlying web of automation and orchestration that makes the whole on-demand thing work.
And that elasticity, that speed, it relies entirely on having a standardized, predictable automation framework.
Yeah.
This isn't just, one simple script. It's a sophisticated chain of integrated components. They all talk to each other to fulfill requests reliably.
Okay, so walk us through the essential pieces of that framework. What are the absolute must-haves to take a request and turn it into a running service?
All right, at a minimum. First, you need something to actually receive the service request. Often that's an API handler.
Okay.
Then, that request needs to be logged into a dedicated database. You need to track its status all the way through the process.
Visibility again.
Always visibility.
Mm-hmm.
Next, you need a scheduler. If you've got potentially thousands of requests coming in at once, you need something to prioritize them, streamline the queue.
Makes sense.
And finally, the core processor, the orchestration engine. This is what actually executes the predefined, standardized workflows to do the provisioning work across compute, storage, networking, everything.
So it's managing this intricate dance between all the different infrastructure silos.
That's a good way to put it.
But what happens when, a dance partner stumbles? Automation can't predict every single possible error or constraint?
No, it can't. And that's why the framework absolutely must include robust, exception-based logic. Meaning if an automated workflow hits a wall, maybe there's a physical resource shortage or a network address conflict or some weird error during middleware installation,
Yeah.
it has to trigger a controlled failure.
Not just crash and burn silently.
Definitely not.
Yeah.
And not proceed incorrectly and deploy something broken.
Yeah.
It needs to flag the specific issue and trigger a manual intervention process. Get a human involved to figure out the constraint and fix it.
Ah, okay. So the automation handles the standard 95%, keeps things moving fast.
Exactly. While gracefully managing the tricky 5% that needs some human oversight.
Okay, now let's talk about that perception of capacity. The cloud feels infinite to the user, but obviously underneath, it's a finite pool of resources.
Right. A shared pool.
So the CMP has to manage this illusion, this perception, using quotas and entitlement.
This is the crucial organizational control layer. Let's start with entitlement. That's all about who gets access to what. It ensures users, or maybe groups of users within a tenant, only have access to the data, the services, the specific infrastructure pools that are appropriate for their job role or their security clearance.
So if I'm not entitled to use the super high security GPU compute pool.
The service catalog won't even show it as an option for you. It's the gatekeeper, basically.
Got it. And then quotas come in after entitlement.
Right. Quotas manage how much capacity someone can consume once they're through the gate.
Okay.
So once you're entitled, you get assigned a preset quota of flexible capacity. Maybe, say, the marketing department gets a total quota of 50 virtual CPUs they can use across all their projects.
And why is that so critical?
It's a critical management tool because it stops one single, maybe resource-hungry request, could be an accidental runaway script, or just an unoptimized job from completely draining the pool for everyone else.
It ensures fair share, prevents noisy neighbors, essentially.
Exactly. Fair share across the organization or the tenant base.
But doesn't this risk bringing back the exact manual bureaucracy we were trying to get away from with the cloud? If every time someone needs slightly more than their default quota, they have to file for an exception.
Ah, yeah. That is the constant tension, the balancing act in achieving cloud maturity.
How do you manage it?
Well, the idea is that most standard, everyday requests will fit within the default quota. That maintains the speed. Requests that exceed the quota are intentionally flagged. They're handled as exceptions.
Usually needing manual approval, budget owner, capacity manager, someone like that.
Typically, yes. But the key, and this is where the CMP design matters, is ensuring the CMP's automated workflow facilitates that approval really quickly. Minutes or hours, ideally. Not days or weeks stuck in email chains.
So the exception process becomes the rare outlier, not the default way of working.
That's the goal. Keep the speed for the common path.
Okay, let's shift back to the orchestration engine itself. You stressed earlier, its job goes way beyond just provisioning the basic infrastructure, like spinning up a VM or carving out a network segment.
Oh, absolutely. The depth of the orchestration capabilities really defines how mature a CMP is. It has to be used to configure the entire stack that runs on that infrastructure.
So not just the VM.
Not just the base VM, no. It needs to integrate with configuration management tools, think Ansible, Chef, Puppet, whatever, to install and configure the actual applications, the middleware, maybe apply OS security hardening rules, all the other IT components running on those resources.
And we're talking about automating ongoing operations too, right? Day two stuff, not just the initial setup.
Precisely. Good orchestration automates key operational tasks. Things like remediating simple incidents, maybe automatically restarting a service instance if it fails a health check.
Self-healing.
Toward self-healing infrastructure, yeah. Or automatically configuring the monitoring system so that as soon as a new deployment goes live, it's immediately visible and starts feeding metrics back into the CMP dashboard.
Right. Now, to do all this complex stuff continuously, at high volume, efficiently, the orchestration engine needs a good library of predefined workflow templates.
Definitely. Standardized building blocks.
But you also emphasized earlier that the web UI, while useful for some things, is often impractical for programmatic control. Why is that API necessity so overwhelmingly crucial for orchestration?
Two main reasons, really, scalability and integration.
Okay.
A web UI is fundamentally a manual interaction. A human has to click buttons. For large-scale continuous operations, especially if you want to integrate the CMP into things like CI/CD pipelines.
Continuous integration, continuous deployment.
Right. You absolutely need API access. Programmatic control lets deployments be triggered automatically by code commits, or by scaling events, or by alerts from other systems.
So if you had to manually kick off a workflow every single time a developer pushed code?
Your agility would just plummet. It defeats the purpose. The API is how the CMP becomes a truly programmable, integrated part of the organization's wider automation toolkit.
All right, let's talk money, financial management. It's got to be integral to the CMP because, well, cloud is fundamentally a consumption-based model.
It is, and you need that visibility. You have to ensure usage actually aligns with business value and stays within those strict budget constraints.
Our sources lay out 5 core functions here that a CMP really must support for effective business management and metering.
Yeah, these 5 are the mechanisms for actually billing customers, whether internal or external, and achieving that overall financial transparency. They kind of build on each other.
Okay, let's start at the bottom layer, cost.
This is absolutely fundamental. This component calculates both the expected costs and the actual costs. That includes the cost of running the CMP infrastructure itself, software licenses, overhead, and the cost of the underlying hardware resources being consumed by the tenants.
So the raw cost data.
The raw cost data, exactly. It forms the basis for everything else, all the reports and charges that come later.
Okay, next level up, the softest accounting method, showback.
Showback, yeah, it's purely informational. Think of it as just a utilization report.
No money changes hands.
No money changes hands. It reports service usage back to the consumer, usually an internal business unit. But critically, it doesn't trigger any fund transfers or revenue collection. It's all about transparency and awareness.
So it basically tells a department, hey, you used $10,000 worth of cloud resources this month.
Exactly. Without actually sending them a bill. The idea is just to influence behavior, increase awareness of costs.
Makes sense. But then if the organization decides IT needs to recover its costs or be treated as a cost center.
Then you step up to chargeback.
Okay.
Chargeback is the actual mechanism for billing internal consumers. It takes those usage stats from the metering engine, links them to predefined internal cost models and rates, and generates formal billing reports for those internal consumers.
And this does cause funds to move internally.
Yes. From, say, the marketing department's budget code to the IT department's budget code. It's internal cost recovery.
Got it. And if you're actually a service provider selling cloud services externally, or maybe an IT org that treats internal departments like formal external customers?
Then you need the next level, billing invoicing.
Right.
This basically extends that chargeback function to generate proper, formal, structured invoices. Often these need to adhere to specific financial regulations or tax rules. It's critical for external providers, obviously, but also for those IT departments adopting a strict internal business model where departments get billed formally, almost like external clients.
Okay. And the 5th function, something often missing in traditional IT, but really essential for cloud's elasticity, forecasting?
Forecasting, yeah. This lets you do what-if analysis. It connects your financial models to potential resource deployments.
So you can estimate the cost impact of future actions.
Exactly. Decide the financial impact of, say, scaling up a service tenfold for a marketing campaign, or retiring a huge, costly legacy application. It's essential for managing that rapid elasticity you get with cloud, helps prevent major sticker shock when a deployment suddenly scales up.
Now, for all 5 of these functions to actually work well, integration and transparency seem key. How does the CMP design need to support that?
Well, the CMP has to create a really clear, direct link between the metered data, those raw utilization numbers we talked about earlier, and the final calculated cost shown on the invoice or the usage report.
Traceability.
Traceability and transparency, yeah. That's absolutely key to building trust in the whole financial model. People need to see how the numbers add up.
And what about setting things up?
The underlying tool, the CMP itself, must make it simple for administrators to define and meter new service offerings. If setting up a new cost profile, linking it to a service template, defining the chargeback rates, if that takes 18 weeks of complex coding or configuration,
It kills the agility again.
it completely defeats the speed advantage of the cloud. So the cost engine needs to be highly configurable, yes, but also straightforward to manage day to day.
Okay, moving up the stack a bit. Service management. This is where the CMP really acts like that central marketplace or the storefront for the cloud.
Exactly. The key functionality here is providing the portal interface that users interact with, and maybe even more importantly, the service catalog itself.
The menu of available services.
The menu, yes. And that catalog functionality needs to robustly support multi-tenancy. You've got shared infrastructure underneath, but each user or tenant should only see the services and products that are relevant and permitted for their role.
Which means strong role-based access controls again.
Absolutely. Governing who can see what and who can request what.
Now, what actually constitutes a formal service offering within this catalog? It's clearly more than just a basic VM template.
Oh, much more. Think of it as a fully quantified product, a complete package deal. A service offering is a formalized, standardized bundle of services, applications, maybe policies that end users consume.
So it defines the resources, like CPU and RAM.
It defines the resources, yes, but also the resource guarantees, the SLA associated with it. It defines the specific metering rules that apply to this offering, the resource management procedures like maybe this tier gets automatic patching every Tuesday and the corresponding billing cycles and costs.
It's essentially the contract.
It is. It's the contract between the provider and the consumer for that specific service level.
Can you elaborate a bit on resource guarantee in a functional sense? What does that look like?
Sure. So maybe you offer a gold-tier database service. The resource guarantee embedded in that offering might specify, say, 99.99% uptime. It might guarantee a certain number of dedicated storage IOPS, so performance doesn't suffer from other tenants. It might guarantee a minimum CPU share, even when the overall platform is busy.
And the CMP has to enforce that.
The CMP has to embed those guarantees right into the deployment template for that offering. So the underlying orchestration engine knows to allocate the right resource priority, the right isolation for anything deployed using that gold tier template.
Okay. Now, to keep things consistent and fast, especially as the catalog grows, the CMP needs an offering repository.
Yes, definitely. This repository acts as the single source of truth for all the defined services. It stores the standardized templates, the blueprints, the associated cost profiles, the SLAs, everything.
And the benefit is?
The benefit is that cloud admins can quickly and easily deploy a consistent, standardized product, maybe a new standard analytics platform template, whenever they need to roll it out to a new department or a new customer. They don't have to reinvent the wheel and rebuild the definition from scratch every single time.
Enforces consistency, reduces errors.
Exactly. Consistency across the entire service ecosystem.
All right, let's shift focus now from the storefront to the warehouse, maybe. Resource management, controlling the underlying supply.
Good analogy. This is about the inventory. The CMP needs to provide that centralized visibility and control over all the virtual resources and the services that are provided on demand, tying those user requests back to the physical reality.
This seems critical for operational integrity.
It absolutely is. And a major requirement here is keeping resource tracking synchronized across all the different layers, from the consumer's request down through the CMP, right down to the hypervisor or infrastructure level.
Which leads us directly to the need for robust tagging and attributes.
Vital. Absolutely vital. Tags supplied by the CMP, and any tags or attributes used by the underlying cloud provider platform, like vSphere tags or AWS tags, they must be synchronized. They need to be consistent.
Why is that consistency so important functionally?
Because tags are often the functional mechanism you use to enforce policies. If the CMP tags a resource with, say, Project Now for Cost Center 42,
Okay.
but the underlying hypervisor platform can't read that tag or the tags get out of sync, then your policy enforcement breaks down. Your chargeback mapping will be wrong. Your security grouping rules might fail.
Okay. So tagging is like the operational glue holding governance together.
That's a great way to think of it. The glue for financial and policy governance.
And beyond tracking, the CMP also needs to simplify the entire lifecycle management process, right?
Right. Provisioning is only half the story. The deprovisioning process is retiring resources, suspending them, scaling them back down. That needs to be just as streamlined using automation.
Why is automated deprovisioning so important?
It ensures resources are fully returned to the central capacity pool as soon as they're no longer needed. It prevents those zombie VMs or orphan storage volumes that just sit there, consuming resources, costing money, doing nothing useful.
Okay. We're also seeing CMPs increasingly offer integrated asset and license management that traditionally lived elsewhere, maybe in a separate ITIL system.
That's a key evolution, yeah.
Oh.
Integrating this capability directly into the CMP means the deployment process can automatically handle granting and maybe even renewing software licenses tied to the deployed resources.
Maintaining compliance automatically.
Exactly. Reduces the admin headache of manually tracking license usage, especially with complex vendor models like per CPU core licensing or per user access licenses.
Okay, finally in the section, let's touch on cloud-to-cloud orchestration. This feels very relevant today with hybrid and multi-cloud setups being so common.
It is highly relevant. Some of the more advanced CMPs do provide this capability. They enable you to orchestrate a workload shift or a migration from maybe your private cloud service into a major public cloud like Azure or AWS, or maybe even between public clouds.
And in that scenario, the CMP acts primarily as a what?
Broker.
A broker is the right term, yes.
So what does that brokering actually involve? What does the CMP do?
It orchestrates the necessary infrastructure steps for the migration. That means it would provision the equivalent resources, VMs, networks, storage in the target public cloud. It would ensure the network connectivity is set up between the source and target. It might manage the high-level process of migrating the applications and data sets.
Okay, but there's a key distinction here about accountability, right?
Yes, critical distinction. The CMP acts as the broker, but it's generally not accountable for the entire migration process outcome itself.
Meaning it orchestrates the infrastructure bits, but it's probably not guaranteeing, say, the data integrity during a massive database transfer or handling complex application-level reconfiguration needed after the move. Its role is infrastructure orchestration.
So organizations still need separate tools or processes for the higher-level application migration and validation work.
Exactly. You need to set realistic expectations about what the CMP broker function does and doesn't cover. It's important for managing project scope.
All right, let's wrap up with the crucial protective layer. If the CMP is the brain, then security is maybe the immune system and governance is the rulebook.
And the stakes here are incredibly high.
Yeah, the criticality of CMP security just can't be overstated, can it?
Absolutely not. Think about it. CMP components get granted sweeping authority, real keys to the kingdom power. They can trigger creation, deletion, modification, control all existing services and infrastructure.
So if someone unauthorized gets access to the CMP,
they could potentially cripple the entire infrastructure. Massive data breaches, complete service outages. It's a nightmare scenario.
So security has to be absolutely baked in every layer. What are the foundational security considerations we need beyond just, a strong password?
Okay, first and foremost, authentication. The CMP needs the rock-solid system. Use standard secure protocols, HTTPS for all web traffic, LDAPS for secure directory integration. Ideally, leverage things like PKI, trusted certificates for encrypting all traffic.
And that protects both the user portal and the back-end APIs.
Both. The human interface and the machine-to-machine communications. You can't leave the API unsecured.
Makes sense. What else?
Second, firewalling and network segmentation. If any part of the CMP needs external access, maybe for integrating with a public cloud service or allowing admin access from outside the data center, you must have a strict firewall between the CMP and those external devices.
Only allowing specific necessary traffic.
Exactly. Segmenting that critical control plane from potentially less secure consumption planes or the public internet. And of course, all the standard server hardening practices apply intrusion prevention, good antivirus, aggressive OS patching for the CMP servers themselves.
Okay. And this level of protection feeds right into the need for properly integrating governance and policy.
Yes, governance is what ensures all those cloud services being deployed and managed actually comply with the organization's own policies, maybe external regulatory requirements like GDPR or IDPA and internal business rules. And it needs to happen automatically.
Right. The CMP needs a robust policy engine that can check compliance in real time, ideally.
In real time. And without killing performance or causing unexpected costs by blocking things unnecessarily, we can break governance down functionally into three key areas: user, operational, and financial.
Okay, let's start with user governance.
This is mainly about managing access and mitigating risks during that self-service process. It's about establishing clear roles, defining very specific privileges for each role, and crucially, ensuring users can only deploy resources using trusted templates or blueprints that IT has already approved and vetted.
Minimizing the risk of misconfiguration or deploying insecure services?
Exactly. Minimizing human error risk. It also includes having automated but still auditable approval workflows for requests that are maybe high risk or unusually high cost.
Got it. Next, operational governance. This sounds like the day-to-day oversight.
It is. This is achieved through consistent, automated, policy-based management of the cloud environment. It absolutely requires continuous monitoring of what users are doing, backed by automated alerts and complete audit trails of all actions.
So automation is key here too.
Key, the CMP should automatically enforce policies. For example, automatically decommissioning cloud resources that have hit their defined end-of-life date, or automatically flagging, maybe even remediating security configurations that drift away from the approved standard blueprint.
Proactive compliance management.
Proactive, yeah. Using real-time data, ideally visible on a single dashboard, to maintain that compliant state continuously.
And finally, financial governance. This brings us back to cost control, acting as a protective layer for the budget.
Right. Financial governance is about establishing guardrails. These can be hard limits, where the CMP just flat out refuses a request because it would exceed the budget allocated.
Or softer limits.
Or soft quota limits that maybe trigger a warning to the user, or kick off an approval workflow to a budget owner before proceeding. It ensures accurate cost management by using those specific cost profiles we talked about, assigned to the service blueprints.
So it's the enforcement mechanism that actually makes show back and charge back effective.
Exactly. It helps ensure cost-effective decisions are being made before the resources actually get consumed and the money gets spent. Hashtag tag outro, guess and hire.
Wow. Okay, so stepping back from all that detail, this deep dive really shows just how expansive and frankly complex a piece of software the cloud management platform is.
It really is. It has to be so many things at once.
Yeah.
Your internal storefront, your accounting department, your highest level security cop, and your automated factory floor all rolled into one.
Its complexity really comes from its purpose, doesn't it? Which is making everything else seem simple, immediate, effortless for the end user.
That's the goal.
Yeah.
It controls that entire life cycle, from the initial request all the way through to retirement.
And, this whole conversation, especially around automation, quotas, governance, it really highlights a core tension, I think, in reaching true cloud maturity.
Oh, so.
While the software, the CMP, it demands and enables extreme agility, extreme speed. Resources should spin up in minutes. That's the promise.
Right.
But if an organization's underlying manual governance processes, things like getting budget approval or assigning an IP address range or updating firewall rules, if those still take weeks of paper trails, endless meetings, manual checks by different teams,
I see where you're going.
then even the most sophisticated, amazing CMP solution just results in the same old rigid IT model you were trying to escape in the first place. The technology outpaces the organization's ability to adapt its processes.
That's a huge challenge for adoption, yeah.
Yeah,
The tech is ready, but the surrounding processes aren't automated to match.
exactly. For true cloud success, it seems the organization has to ensure its operational processes adapt to exploit the automation the CMP offers. Which kind of leads to a final thought, a question for you, the listener. As you look at your own organization, your internal processes, which existing organizational process do you think is the absolute hardest to successfully automate within the context of deploying a new CMP? And maybe more importantly, why does that manual step persist? What's holding it back? Something to think about.